Okay, boiling point changes in when an ester is formed from its acid and alcohol. First off, all of the molecules have weak dispersion forces between them. So we can put dotted lines joining together the methanol molecules and dotted lines joining or attraction between the two ethanoic acid molecules, and similarly for the ester. So I'll have this colour as dispersion forces, but they're weak. For dipole-dipole, we need to have an electronegative element present and a positive and negative end. And we've got a dipole-dipole possible here between ethanoic acid molecules, so there'll be an attraction between that slightly positive carbon because that oxygen's taken more than its share of electrons, so there'll be an attraction between it and the electronegative oxygen on another ethanoic acid molecule that's taking more than its share, plus attracting minus. So there's dipole-dipole possible between ethanoic acid molecules. They're also possible between the ester once it forms for the same reason, that we can see this slightly positive carbon on this molecule being attracted to this slightly negative oxygen on the other one. So dipole-dipole. And I'm making those dots just a little bit bigger because the strength of a dipole-dipole is very much bigger than the attraction, just normal dispersion forces. So I might draw this big as well. Our fourth type of attraction between molecules is the strongest attraction, and it's hydrogen bonding. So it's still a type of polar molecule, but it's the best type of polar molecule because the oxygen, or the electronegative element in general, is directly bonded to a hydrogen. So I can certainly have a hydrogen bond between my ethanols, and I'm trying to draw those as big attraction. So that's a slightly positive hydrogen being attracted to the slightly negative oxygen. So hydrogen bonding is possible in methanol, and I have it possible also in my acid, because that slightly positive hydrogen will be attracted to that slightly negative oxygen, and that attraction is strong, hence I'm drawing it as big dots. But we lose the capacity for hydrogen bonding when we form an ester. We no longer have the hydrogen bonded directly to the oxygen. So to summarise, for methanol, we have dispersion forces, we have and hydrogen bonding. To summarise for the ethanoic acids, yes, there's dispersion forces present. There is dipole-dipole, represented by the blue attraction, and there's hydrogen bonding. And summarising the attraction between the ester molecules, we have dispersion, we have dipole-dipole, but no hydrogen bonding. So that means that we'd expect the boiling point of our acid to be greater than the boiling point of our alkanol, and the smallest boiling point we expect to be the ester, because it has less types of attractions between molecules. Thank you for watching.